Welcome. What we're going to do here today is go through how to balance chemical equations. For this, there is one major point, one reason why we must balance all chemical equations, and that's so that the chemical equation follows the law of conservation of mass. Without balancing the chemical equation, they violate the law of conservation of mass, which throws a big kink in any chemistry experiment or any chemistry work. Now, the guiding principles behind balancing equations, the mass of the reactants or the number of each reactant must be the same as the number of each product. As soon as the number of each element as on the reactants side is the same as the number of each element on the product side, the masses of the reactants will be the same as the mass of the products in your chemical reaction. The method of balancing chemical equations will make use of coefficients. These will be big numbers written before each chemical formula. One of the most common mistakes that I usually see that students will end up making is they'll end up manipulating the formulas in the chemical reactions. And that is not allowed. You are not to manipulate any formulas as you try to balance the equation. So, with these things in mind, let's get to work. One thing that's always going to be helpful is a periodic table, so I always have one handy just so I know where my elements are coming from. So the first reaction that we're going to investigate is a reaction between magnesium and oxygen, where magnesium, a metal, will combine with oxygen, a nonmetal, to form magnesium oxide, MgO. Now, the reason why this formula MgO is MgO and not MgO2 is because of the charges of each of those. So the charge of magnesium is positive 2, the charge of oxygen is negative 2. We only need one magnesium atom for every one oxygen atom to get the net charge to be 0, and that's why we have the formula MgO. For extra information on that, you should check out one of the previous videos on writing formulas. So now we need to balance this, because when I look at this equation, I'm going to divide it in half, and I'm always going to divide equations in half at the yields symbol. So at that arrow, that's where I'm going to divide my reaction in half. I need the total number of magnesiums on the left to be the same as the magnesiums on the right. I need the total number of oxygens on the left to be the same as the number of oxygens on the right. As soon as they do, the equation is balanced and it follows the law of conservation of mass. So let's get to it. The number one rule that I always have is always and only add to the side that has less and start at the beginning. So let's start at the beginning and always and only add to the side that has less. There's one magnesium on the left, one magnesium on the right. So magnesiums are currently balanced. Next, element, oxygen. There are two oxygens on the left, one oxygen on the right. So always and only add to the side that has less. Now here, many people will try to just simply add in one more oxygen. The problem with this is you can't just add in one oxygen. You have to add in one whole additional magnesium oxide. This compound, you can't get one without the other. They have to come together all the time. So this is telling me that I have two magnesium oxide molecules on the right-hand side. Now we have two oxygens on the left, two on the right. But when I did that, I screwed up my magnesiums. I have two magnesiums on the right here, but just one on the left. Always and only add to the side that has less. So I'm going to go ahead and write another magnesium here on the left. Going through again, two magnesiums, two oxygens, two oxygens. How many units of each, how many atoms or molecules of each did I need? Well, I needed 2 magnesiums. I only needed one oxygen, and I needed 2 magnesium oxides. So my final answer, my final balanced chemical equation, would be written as this: 2 Mg plus O2 yields 2 MgO. This would be my final balanced chemical equation. This follows the law of conservation of mass. You'll notice I did not write my 1 there. You do not need to write coefficients of 1. All right, let's take a look at another chemical reaction. This chemical reaction that we'll look at is the reaction between aluminum and cupric or copper 2 chloride. Here, again, what we should do is divide that reaction in half at the yield symbol. It's going to be my visual barrier, so I know the numbers on the left must be the same as the numbers on the right. And then start at the beginning. Always and only add to the side that has less. 1 aluminum on the left versus 1 aluminum on the right. Balanced. 1 copper on the left versus 1 copper on the right. Balanced. Last element, chlorine. 2 chlorines on the left, 3 chlorines on the right. Now, always and only add to the side that has less. This side has less. So remember, I need to add in a whole nother CuCl2 unit, a whole nother compound here, a whole nother molecule there. CuCl2. Now I have 2 plus 2, 4 chlorines on the left, 3 chlorines on the right. Always and only add to the side that has less. This will give me 6 chlorines on the right versus 4 chlorines on the left. Always and only add to the side that has less. And be patient. Patience is a virtue here. 2, 4, 6 chlorines on the left, 6 chlorines on the right. Finally taking care of chlorines. Now look, I made a mistake, or I didn't make a mistake, but I added extra coppers there. So I need to add more coppers on this side. I have 3 on the left. So let's make there be 3 on the right. Now I have 3 coppers on the left and 3 coppers on the right. Coppers are balanced. My chlorines still balanced. My aluminums, however, I've got 2 on the right, just 1 on the left. I've got to add in another aluminum on the left to get them to balance. How many units did it take to get this to balance? 2 aluminums, 3 cupric chlorides, 2 aluminum chlorides, and 3 coppers. To write this out, my final balanced chemical equation that follows the law of conservation of mass, 2Al plus 3 CuCl2 yields 2AlCl3 plus 3 Cu. This is my balanced chemical equation, which follows the law of conservation of mass. This was a single displacement reaction. Next up, our final example here is going to be the reaction of lead to nitrate and potassium iodide, forming potassium nitrate and lead iodide. So, as you might want to guess, we should start at the beginning and always and only add to the side that has less. 1 lead versus 1 lead. Oh wait, don't forget to divide that reaction in half. So you had a visual barrier. 1 lead, 1 lead. Now you see this NO3. I called that nitrate when I was walking through the reaction. Notice that this nitrate here is the same as over here. So this NO3 is the same on each side. This is called nitrate. When you see this, these are polyatomic ions. Polyatomic ions. Which is NO3 with a -1 charge, a many-atomed ion, so a many-atom charged particle. Since it's the same on each side, all I have to do is notice there's 2 nitrates on the left, but only 1 nitrate on the right. It's going to make my balancing job a little bit easier. Instead of balancing nitrogens and oxygens separate, I'm going to balance nitrates as a whole unit. So 1 lead, 2 nitrates versus 1 nitrate. Always and only add to the side that has less. 2 nitrates, 2 nitrates, because that 2 gets distributed. 1 potassium, 2 potassiums. Always and only add to the side that has less. 2 potassiums, 2 potassiums. 2 iodines, 2 iodines. And we're balanced. How many units of each? 2 units, 2 units, 1 unit, and of course 1 unit. To write the balanced chemical equation, all I need to do, Pb parentheses NO3 taken twice plus 2 Ki yields 2 KNO3 plus PbI2. And this chemical equation is now balanced, and it follows the law of conservation of mass. So, what should we do? Remember, when you are balancing a chemical equation, the reactants need to be the same as the products. You can use a coefficient. The coefficients are these big numbers out front. But you may not manipulate any of the formulas. So when you are given a formula like KNO3, you cannot change it to be 2 potassiums, 2 nitrogens, and 6 oxygens. This 2, this coefficient, would be distributed throughout. This 2 is telling me how many molecules I need. All right. By changing the subscripts, we would be changing the chemical structure, which would be violating the rules of chemistry. So we should not do that. All right, I think that's all for balancing chemical equations. It's going to be very mathy when you're thinking about it, and there are going to be some tricks. You won't always have to write out the numbers of units of each reactant and product like I've done here. It'll get faster, and you'll be able to start doing them in your head after a little bit of practice. So good luck and get practicing. Thank you.